ऑप्शन प्राइसिंग मॉडल। तो इसके लिए ये एक रिस्क न्यूट्रल मेथड से कैलकुलेट करते हैं। सो दिस मॉडल रिक्वायर्स सम इनपुट्स। इनपुट का मतलब कुछ वेरिएबल्स, किन किन वेरिएबल्स की ज़रूरत पड़ेगी इस मॉडल में। तो what are the inputs of this model are, what are the variables? So it requires 5 inputs. What are these? One is spot price. We need to know we should have the spot price. Then we should have the exercise price or strike price. Then the time left for expiration, T is the S is the spot price, T is the time left for expiration, and we need to have we need to know the variability in the price, variability or volatility in the price. Sigma is the variability in the price. Risk-free rate, R is the risk-free rate of return, and these 5 inputs are required basically for calculation of the call or the put option premium. So what the model is, it is based on some assumptions. There are some assumptions of this model. Assumptions are basically this model is used to find out it is applicable for call option in European style. तो ये जो मॉडल इनिशियली जिससे हम फॉर्मूला कैलकुलेट करेंगे, इट इज़ फॉर कॉल ऑप्शन इन यूरोपियन स्टाइल, फर्स्ट पॉइंट. सेकेंड, प्राइस ऑफ शेयर, we are assuming that price of share changes continuously. Third, we are assuming share price has log normal distribution. Fourth is transaction cost and taxes does not exist. Fifth is funds can be borrowed at risk-free rate of return, and dividend we are not considering. Dividend is not considered. So hedge ratio is indicated as normal distribution of D1, value of D1. Now what is D1? D1 is equals to log S naught upon E plus R plus 0.5 into sigma square की power into this divided by sigma under root T. This is capital T. Capital T is time to expiration. R is risk-free return. S naught is the spot price. E is the expiration price. And sigma is the volatility. This we have discussed. What is D1? After calculating D1, we calculate the D2. D2 is equals to D1 minus sigma under root T. C naught is equals to the C naught is the call premium. It is equals to the S naught into n raised to the power d1 minus e into e की power minus rt into n d2. Now what is the value of what is this n d1 and n d2? N d1 is the normal distribution log normal distribution value of d1 log normal distribution value of d2 and पुट ऑप्शन के प्रीमियम का फॉर्मूला है सी नॉट माइनस एस नॉट प्लस ई इंटू ई रेज टू द पावर माइनस आर टी आर इज द रिस्क प्रीमियम सिग्मा को और क्या बोल सकते हैं स्टैंडर्ड डेविएशन ऑफ रिटर्न्स ऑफ एसेट जो भी अंडरलाइंग एसेट है उसका रिटर्न्स का स्टैंडर्ड डेविएशन सो टाइम जो है टी वी हैव टू टेक इन. So if it is given in months, so we will convert it by dividing by 12. We'll convert it into years. So this is how the Black-Scholes option pricing model is used. Any doubt in this model? We have the formulas and we have to calculate the values. नॉर्मल डिस्ट्रीब्यूशन टेबल आपने स्टैटिस्टिक्स में पढ़ा होगा. कैसे देखते हैं? पढ़ा है? Then we have after this Black-Scholes option pricing model. How many models we have discussed? We have discussed two models of option pricing. One is binomial model and second is Black-Scholes option pricing model. बाइनोमियल मॉडल दो तरीके का था, रिस्क न्यूट्रल मेथड एंड ऑप्शन इक्विवेलेंट मेथड. हम दोनों डिस्कस कर चुके हैं. Any doubt in this? इसके बाद हम डिस्कस करेंगे we have some option Greeks. We have a term option Greeks. Option Greeks means sensitivities. So इसका मतलब क्या है? That option value depends on 5 parameters. We are saying Black-Scholes model में हमने देखा था ना that it depends on 5 parameters. What are those parameters? One is the spot value of underlying asset. Second is the exercise price, strike price. इसको भी denote by S. कॉट प्राइस, एक्सरसाइज प्राइस यानी कि एक्स, थर्ड इज दी टाइम remaining to expiration, denoted by n, and fourth is risk free rate of return, denoted by small r, and fifth is the standard deviation of asset returns, that is denoted by sigma. These factors has some relationship with the value, मतलब ऑप्शन प्राइस क्या रहेगा, ऑप्शन प्राइस इनके चेंज होने से ऑप्शन प्राइस में क्या चेंज होगा, जब ये चेंज होंगे तो ऑप्शन प्राइस भी चेंज होगा, एंड वो जो रिलेशन है उसको कुछ ग्रीक लेटर से हम इंडिकेट करते हैं. सो वी आर सेइंग that variation in the option value with respect to determinants, we are saying variation in option value is dependent on the factors affecting it, है ना. So it is dependent the determinants on its determinants, and these determinants are these are denoted by Greek letters, and that is why the term is option Greeks. नाम दिख रहा है option Greeks. What is the meaning of Greeks? Greeks means the sensitivities of option price with respect to these 5 factors. So when we calculate, अब यहाँ पे ध्यान देंगे, when we calculate the change in asset price, so इसको यहाँ दिखाते हैं. So here is the Greek letter. We have some Greek letters, and these letters are with respect to the determinant of option price. So we have a Greek letter delta, and delta defines what is the change in, how much the change in asset price and what is the change in the option value. Theta is for time left for maturity. What is the time left for maturity? And we have gamma. एग्जाम में पूछा जा सकता है, what is the meaning of theta, what is gamma? Gamma is change in price, that is volatility. Change in price, no, it is not volatility, it is sensitivity actually. Rho, change in risk free return, and then we have vega is change in volatility, that is vega. So how the standard deviation is affecting the option value. So if we want to calculate these values, these symbols, like how they are calculated, so we have some